Dynamic updates for DNS services like Bind are very useful, particularly when you use DHCP because it allows you to access a device via its hostname, and it makes no difference if the IP address changes. And it has uses beyond that, as I've found when deploying my own ACME server. Now, I did post a video about how to configure dynamic DNS for Bind, but for a standalone server some time ago. But it's a bit more tricky when you're running Bind as a container because of file permissions. So, how do you configure a Bind container to support dynamic DNS? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, because this video is specifically about configuring dynamic updates in Bind, I'm going to assume you already have Bind running in a container. If not, I do have another video which shows you how to create your own Docker image to run Bind in a container. What I won't be covering, however, is how to configure an end device like a DHCP server, because it really depends on what that end device is. But I do have another video on how to configure Kia to support dynamic DNS, for instance. Now, for a long time, DNS servers have typically only involved using static records. So in other words, you'd have servers that have got static IP addresses, and an administrator would maintain the zone file, which contains all the actual details of those servers and their IP addresses. But of course, then we've got dynamic DNS. So for example, you can have a DHCP server update the DNS server with IP addresses that have been leased out to actual hosts. The challenge then is that Bind now actually needs write access to the actual zone file. It needs to make changes to it. In addition to that, in the case of at least Bind, it also needs to be able to create a journal file in the same directory where that zone file is, and that causes quite a bit of a problem. So by default, if we just have a look inside of the actual container, we'll have a look at the permissions for /etc/bind here. So basically I'm just running this ls-l command to have a look in the /etc folder, and I'm filtering it out to anything named bind. And if you look here, you can see that root as the owner, bind the group, has got read-only access. Now that's deliberate because you don't want the actual bind user being able to modify your configuration files. The reason being is if the service ever gets compromised. But like I said, if you want to use dynamic updates, well, that's not going to work because the bind user needs write access. So fortunately, at least in the case of this installation that I've got, we've got another folder /var/lib/bind. If we look at that, what we've got is root has got full access, but also do any users within the actual bind group. So it really makes more sense to use /var/lib/bind for dynamic DNS, specifically to put your zone files in. Your configuration files stay in /etc/bind, and then if the service gets compromised, at least it can't actually change the main configuration files. So that is basically what we're going to do, is to move our zone files into this folder instead to give Bind the necessary permissions to be able to make changes. Now, I did try to tighten things up as best as I could. My goal really was to have sort of like a split, if you will. So you've got dynamic records that are separate to static records. The only trouble is Bind causes a lot of complexity, and it's just, realistically, it's not practical. It's doable, but it's just not practical. So what I'm going to have to do is just put the entire zone file plus any static records that go with it into /var/lib, and then try to lock it down as best as we can later on. So first thing I need to do is to create a new folder on the host, because this zone file needs to be able to survive an actual restart of the container, for example. So all my files are in Bind9, which is in the home folder of this actual Docker user. So we're going to create this folder here within there. Then I'm going to move my two zone files. So that's the forward lookup zone. We'll move it from here to here. And then I'll do the same for the reverse lookup zone. So just move that one as well. Now, because I've done that, what I'm going to do is I'm going to have to edit the actual configuration file, because at the moment it's pointing to 2 zone files in /etc/bind. So I need to change that and actually tell it to go to /var/lib instead. So we'll change that to /var/lib. Same there. So that's all I'm doing, is I'm just changing the actual location as far as the config file goes. So we'll save that change. Now, I'm actually running Docker with Docker Compose to actually run all of my containers. So what I'm going to have to do is just take a quick backup of this actual file, which for me it's called docker-compose.yml. Now that I've done that, I'm going to edit my Docker Compose file. So I'm just going to use nano to edit that. Then I'm going to have to go and search for Bind9 here. Now, at the moment, I'm pointing some mappings to /etc/bind. I'm going to take those 2 lines out and I'm going to replace them with a new entry, because this time round I'm just going to map the entire actual folder across. Now, the reason I'm not mapping the entire /etc/bind folder is because there are other files within that folder that exist on the container. If I do this /etc/bind, what happens effectively is all of the files that the container currently has in /etc/bind would just disappear and be replaced by whatever I've got in this folder on the host. I don't really want to maintain every single file, because these are just default files, but they do have a purpose. Things would break if those files disappeared. So for me, it's easier just to reference the specific files that I need in /etc/bind. If there's ever an update to bind where a new file appears, or if one of the existing files gets modified, it doesn't really matter. It already exists in the container, or at least when the container gets updated. All I need to be worried about is these 2 files here that I've specifically changed. Now, what I am going to do is I'm just going to tighten things up a bit. I'm going to make sure that these are read-only. They should be anyway, because the permissions on the host lock it down, but there's no harm being extra cautious and adding that extra level of security. By default, you get read-write access when you're mapping an actual folder through, so I'm just going to leave that as is. It's equivalent of me putting in, say, that basically, but there's no need because that's the default anyway. So those are the changes I need to make. So we're now mapping through our 2 config files. I deliberately map through this resolve.conf file so that the host and the actual container are in sync when it comes to resolve, because that can cause problems. And then now that we've moved the zone files across, I'm going to map that entire folder. So we'll save that. Now, because this is quite a big change, I'm actually going to stop the actual container. And then what we're going to do is just get Docker Compose to bring it back up again. So now that's done. I'm just going to double check just to make sure that it doesn't have any problems. If there's any typos or anything like that, well, the container just won't run. So it's been up for 12 seconds, which is good. So it looks as though it's working fine. So in which case, I'm just going to test that resolution is actually working. So I'm just going to use the actual host command to do that. I'm going to check if it can actually resolve this fully qualified domain name. So yeah, it's resolved that to an IP address, and I'll just double check reverse lookup is working as well. So now I'm trying to get it to resolve an IP address to an FQDN. Yeah, so it's referencing that as my PVE Demo 3 server. So we've now actually moved the files into a folder where in a normal server, Bind would actually have write access. The only trouble is we're dealing with containers, and now we're going to have to deal with some additional challenges when it comes to permissions and ownership. Now at this stage, Bind is doing DNS resolution, but the only problem is if we try to introduce dynamic updates, it's not going to work. And the reason being is permissions. The actual user in the container can't actually write or make changes to files in /var/lib/bind. So if we actually have a look at what the permissions are at the moment. So I'm going to take a peek inside of the actual container, and I'm just looking for any folder in there in /var/lib that's got the name bind in it. So I'll hit return, and there you go. We've got one folder here called bind. The user has got, well, basically full rights. The group has got read-only and executable rights, and then others have got read and executable rights. But the key thing is 1001 for the user ID and the group ID. So the container doesn't even recognize this user and group. So it's not going to work. And the reason being is when you actually map an entire folder across from the host to the container, it inherits the actual permissions and ownership from the actual host. So these are things we need to address. Now, what you could do, probably the common and most simplest way, is to map the user ID and group ID of the host user to the actual user in the container. But I've been looking for something that's a bit more secure. I want to use a shared group. So that way the user in the container and the user on the host are both members of a group, and they've both got write access to files as well as the directory itself, this /var/lib/bind. And believe me, I've been trying for a long time. I even resorted to having a nice conversation with ChatGPT for quite a while, and eventually we managed to get things working. So either way, even if you just want to do, just the basic mapping of the actual user ID and group ID, you have to create your own image. Basically, you have to need to make some changes to the default image that you would get for Bind. So in my case, what I'm going to do is create my own Bind image. It's going to go in this folder called images/Bind9, because I keep all of my images in this images folder, and Bind9 is the name of this container. We're going to swap over to that actual folder, and then what we're going to do is to create a Docker file, because that's typically the name that gets used for creating images with Docker. And I'm just going to use Nano to edit this. Then what I'll do is copy and paste in what me and ChatGPT had a long conversation about. There was things that were introduced in here that made absolutely no sense. There were things that didn't work. There were things that would make the security worse. Yeah, it was a long conversation, shall we say. But this for me does actually work, at least the way I want it to. So you've got to start with at least a base image, and I'm using Debian here. And then what you need to do is to create a new user and a new group. So I'm listing the details up here about the name of the user, the name of the group, along with the IDs for the user and group as well, just to make it a bit easier if you want to change these to something else. Then what we do is to install Bind9 and ACL. So we run apt-update just to make sure we've got everything up to date in terms of packages. Then we run apt-install to install Bind9 and ACL. So we're always going to need Bind9, but we also need ACL because we're going to fine-tune the security using ACLs lower down. Now this is quite interesting. This was something I'd never used before, something that ChatGPT suggested, which I think is actually quite useful in that it actually tidies up all of those downloads and removes any files in /var/lib/apt/lists, then what it should do is actually reduce the size of the image. So instead of having all of those files in your folder that you're not going to use now, it just takes them away. So it supposedly shrinks the actual size of the image by doing that. In any case, what we then need to do is to create a new group. Then we'll create a new user. It doesn't need to basically log in at all as such through SSH, for instance. That's better for security. It doesn't need an actual home folder at all. So once it's done that, that's where things then start getting interesting in terms of the ownerships and the permissions. The reason being is that I tried this, and try as I might, I just couldn't get it to preserve certain permissions, and it was ending up in a conflict between the host user and the container user. And it was only when I was having this conversation with ChatGPT that I got a better understanding of this setting, the set gate over here, which is used to basically preserve permissions that are coming from the actual folder itself. But in any case, it goes through this process because we've created a new user and group. We've got to actually change the ownership and permissions to actually match this new user and group. So it goes over to /var/cache/bind, which is a folder that Bind uses. So it's changing the permissions and ownerships there. It also goes over and changes the permissions for /etc/bind, because again, the actual user account that we're going to use is going to actually need to be able to at least read the config files in there. And then it goes through the process of actually changing those permissions for files as well as for any directories that it finds within /etc/bind. Now, once it's done that, it then goes through and tightens up the security on /var/cache/bind so that they don't change. The idea is if a user actually modifies, creates a file, by default it would normally go through this process of it would stamp the file with its own name and its own primary group. So we're just locking that down to say, look, make sure we don't change any permissions. We want to maintain the permissions of the actual directory itself. And then after that, it's pretty much the same as what I would have done anyway, where we switch over to the actual user account. The only difference now is, we need to run the actual bind command, which is what we've got here called named. We run that in the foreground because if you run an actual service, for example, in a container, or you run something in the background, the container starts it up and then it just stops. You need to have something that's running in the foreground to keep the container going. So that part's pretty much the same, except what it's done is it's to introduce this umask 002, and it's all about preserving this whole idea of maintaining the permissions that have been defined within the actual directory so that they don't get changed every time a file gets modified or a new file gets created. So yeah, there was a lot of discussion, shall we say, regarding how this would all get set up. There was, at some point, it was trying to introduce /var/lib/bind into all these permissions. And like I pointed out, well, that's kind of pointless because we're actually mapping the entire folder from the host to the actual container. So there's no point defining it within the actual image because it's just going to get overwritten by the mapping anyway. So yeah, that was in to begin with, and then I took it out because it was pointless. So what I'm finding is AIs like ChatGPT, Gemini is the same incidentally, is that you really need to know what you're doing, or at least have some idea of what you're doing. Otherwise, it'll tell you to do things that don't work. And it can get really interesting because you'll be given like instructions, oh, do this, 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 and this. You'll implement them. You'll then say, well, it doesn't work. And you'll show them what you did, in other words, exactly what they told you. And it's a case of, oh, no, that's not going to work. And you're like, well, why? Why did you tell me to do that when you know it didn't work? It really questions what these things know. but they're pulling information as far as I can tell from various sources. So it's a bit dubious calling them an artificial intelligence. They don't actually know things, shall we say, or if they do, they're being very interesting in terms of what they're telling you. And they can also change their mind. On one day they tell you to do it this way, and the next day they're telling you to do it that way. It's, I would say, the conversation can get somewhat heated. So they're definitely useful. You certainly learn things, but it helps if you've got some understanding yourself of what you're asking them to do. In any case, we're going to save that file. Now, the next thing I need to do is I just need to go and double check what images I've already got, because I need to create a new image. So at the moment we're up to version 0.2. Basically I've been pulling images from another platform that I'm actually building my images on, but in this case for this demo we're going to have to create a completely new one. So the next version number is going to be 0.3. So what I'm doing is I'm going to run docker build. Now I'm using -- network equal to host because I've got access to internet DNS locked down. Only DNS servers have got access. So I'm going to force this to use the internal DNS servers. I don't want to use caching because sometimes that can cause problems. So it's going to have to pull everything down from the internet to do this. I'm going to call this Bind9 _ image, and it's going to be version 0.3. So, and it's going to be working in the actual current folder, hence the dot there at the end. Now this is going to take a while, but the reason I'm creating versions is, well, it's a standard practice to create versions, but also because, well, things can get rather interesting if you don't. If you create a latest version and then you go and reconfigure your container to use that latest version, if you don't have an older version available that works, you could run into problems, because then if the actual container doesn't come up, you don't have a DNS server, and then you can't rebuild your actual image to fix the problem. So it always makes sense to use versioning. Otherwise, yeah, things can get rather tricky, shall we say. Anyway, I'll leave this running and then we'll come back once it's actually finished. So this is now actually finished and it's built a new version. So what I now need to do is just to go over and update the Docker Compose file that I've got. So again, I'm just going to use Nano to edit my Docker Compose file. And then what I'm going to do is I'm going to point the container to my new image. So at the moment it's referencing the latest image that I've got, but going forward I wanted to use version 0.3. So I'm just commenting that line out just to make it a bit easier for me to roll back. I've still got a latest image, but I've now got a new image to tell it to use. So it's going to be easy to just flip backwards and forwards between the two and still maintain a working actual container essentially. So we'll save that, but there's more permissions and ownership things we need to fix. So now that we've got our new image created for Bind, what we now need to do is to make some changes to the host. The idea is we're going to have a shared group. The host user and the container user are going to be members of that same group, and then both of them can actually modify files that are being shared between the two. So to do that, I'm going to have to swap over to an account that's got sudo rights. This user here, it's a member of the Docker group, so it can run Docker basically without having to put sudo commands in. It does get elevated privileges essentially because it's a member of the Docker group, but it can't actually run commands using sudo. So in which case, over on here, what we need to do is to create the same group. So I call that bind group, and it's number 5001 in my case. That's my password. Next, what we're going to do is to change the ownership of /var/lib/bind, at least as the actual host sees it. So this is in the actual home folder of my Docker user within that Bind9 folder there. And we're changing the permissions over. So, I mean, you've got to have a user as the owner, but what's mostly important is the bind group as the actual group. And then what I've got to do is set the permissions. And again, it comes back to this set git, something I wasn't particularly aware of at the time. The whole idea is we want permissions to be preserved based on whatever's been set at the folder level. So just apply that. And then what I need to do is to add the user, the Docker that I'm using, to this actual group. But what I also need to do is I need to start applying ACLs. Otherwise, what will happen is new files might get created, for instance, by the container user, but then the host user doesn't actually get access to them, or at least can't write to them, I should say. So I need to install ACL on the host. So just wait for that to finish. It's thinking about it. And then what we're going to do is then start setting an ACL just to make sure that the group has got read-write permissions. Now, if this computer gets backed up, others are going to need read access, so I'm going to enforce that as well. So it's basically the same, except it's for others and read access. Back over here for our Docker user, I need to exit out and I need to log back in again, otherwise the changes don't take effect. And just go back to the home folder. Then what we need to do is to bring this container down, because we needed to use a completely new image now. And then we'll start that back up again. So I'll go through the process. There's only one container to bring back up now. Then I'm just going to double check. So it's been up for about 8 seconds, 10 seconds. So yeah, that seems fine. It's not having an issue. And you can see we're using version 0.3 now. So what I do need to do though is just make sure it's actually still working. So can we do host name resolution? So forward lookups are working. So just double check reverse lookups. Yep, they're working as well. And I'm using different host names and IP addresses just to avoid any caching, basically. Then $64 million question is, can the actual user in that container actually write to the actual folder? Can it create a new file? In this case, I'm just going to call it test.txt. I'm just going to create it using touch. So it doesn't come back with an error, but we'll just double check. So in that case, I actually went into the container essentially and got that user to create the file. Now I'm actually going to look in the folder on the actual host computer itself. And there you go, there's our text file there. So we don't recognize the user that's in the container. So we're seeing 5001 for the actual user. I don't particularly mind that, to be fair, because bind group is the group and it's got read-write permissions to that file. And I can double check that by actually removing the file from the actual host itself. So I'm just going to use remove to remove that test file. So if you have a look in there now, it's gone. So from what we can see, the user that's in that container does have write permissions to /var /lib/bind. It can create new files, which is extremely important because it's going to be creating journal files to keep track of the actual changes. We've got read and write permissions for the bind group. So even though these files were created by this user, Docker Manager, anyone who's a member of that group can now make modifications to these zone files, and it has to do that. Ideally, I want it to have a separate static file, like I said before, and a separate dynamic file. I don't want to have subdomains. It's just going to get too complicated having dynamic posts in one subdomain and static ones in another subdomain. So I was trying to find a way to have a static file that Bind couldn't touch. But because of the way that Bind works, that's not possible, or at least not practical, I should say. It's going to completely create a new zone file every time it's like flushing changes to the actual disk. It just completely rebuilds the zone file, for example. So no matter what I was doing, no matter what I was being told by either ChatGPT or Gemini, they came up with some interesting strategies, but they didn't work. Again, it was a case of, yes, do this, this'll work. And then you say, well, actually, it doesn't work. Oh, no, that's not going to work. Like, again, like, why did you tell me to do it this way if you knew it wasn't going to work in the first place? So it was a long, slow, laborious process of trying to get to it, even to this, just something like this. But at least now I've got a case where I've got two users, one on the host and one on the actual container, that have both got the right permissions. So at least that part is there. So next we need to start thinking about, well, what about actual dynamic updates? How do we do that within a container? Now, dynamic DNS or dynamic updates is extremely useful. Typically, you'd be pairing up your DNS server and your DHCP server. The idea is the DHCP server leases an IP address and then it updates the DNS server. And then what you can do is get access to the computer through its host name, and it won't matter if the IP address keeps changing. What I'm also using it for, though, is for an ACME server. So what this allows me to do is to actually use DNS challenges, which are more secure than direct challenges. In any case, when it comes to Bind, it's pretty straightforward to set up. The only thing is you want to lock down the access. You don't want any user or any computer being able to make changes. So what we're going to do is to actually create a key. So the idea is, if you want to make changes, you need to be in possession of that key. We're going to use the tsig-keygen command to do that. You get it as part of the Bind9 software when it's installed. So it's not on this host, and I don't want to go to the trouble of installing all that software when realistically I can just run this through the actual container. The algorithm we're using is HMAC-SHA-256, but you could use something stronger. As an example, in this video we'll set this up as if you're going to use a DHCP server to do the changes. So for that reason I've called the key dhcp.key, but you can use whatever name you like here. Now I don't want the output going straight to the screen. I'm going to actually get it to create this file, dns.keys.conf, but I've got two greater than symbols, which basically means that the output is appended to the file. In this case, we're just doing this for the first time, in which case it'll create the file at the same time. Now, if we look at the file, what you'll see is there's the name, there's the algorithm, and there's the key. In other words, this is all in plain text. So you've got to be very, very careful with this actual file, because anybody who can get access to it knows all of the information. It's not encrypted. So for that reason, I'm just going to jump over to this user that's got sudo rights, and we're going to lock this down. We're going to change the ownership. So we've got a host user plus the bind group, because the container needs to be able to read that file. And then we're going to change the permissions as well. So basically the user, in other words, the user on the actual host here, has got the full write permissions. The actual user on the container has got read permissions, and everybody else has no permissions at all. Now, this throws up a bit of a conundrum, I suppose. If we go back to earlier, I allowed others to have read access to the zone files. The idea was, well, if you're running backup software, then it needs to be able to read those zone files, surely. The trouble is, we're blocking access to others here for this particular file, and we have to, otherwise Bind will complain. So it introduces a bit of a conundrum, I must admit, when it comes to your backups. But I left the situation as is, just to explain that dilemma that you've got. I suppose if the backup account were to back up the zone files and be able to back up this, you could have the potential that you've got very sensitive information staying on an actual backup server that who knows who can get access to that. So maybe it is better to do it this way, let the zone files be backed up by the backup account, and then you use your own user account to back up this. Better still, actually encrypt it, upload that to your backup server, for instance, and then because it's encrypted, it really keeps this a lot more secure. So there's different ways, I suppose, to handle it. It's just, as I say, it's a bit of a conundrum as to how you deal with it. In my case, what I think I'll do is I'll just be running an actual command to just regularly back this up as a separate file. But in the grander scheme, to be fair, I'm going to get Ansible to look after this all anyway, so it's not that big of a deal. I don't have to actually back up my containers because Ansible will be able to create the container, create the actual files, do all of the dynamic updates that are needed for the static records, and it'll be able to keep an eye on this key, and it'll be in possession of the key. Ansible will get backed up in its own separate way, and so on. But it's, as I say, it's just a bit of a dilemma, shall we say, and I just wanted to highlight those two problems, and that, yeah, we can still allow access to the zone files maybe, but we don't have that luxury when it comes to the actual keys. I mean, yes, you could grant the actual backup user access to the actual group, but then it's got write access to the actual zone files. So yeah, needs a bit of thought, shall we say. In any case, now that we've set up the permissions here, we'll come back to here. What I need to do is to let the actual container know about this file. So I'm going to edit my compose file because that's what I'm using. Then we'll go and find our bind container, which is here. And I'm going to add a new file in, a new line in, I should say, to actually create the new mapping. And although we've actually got this locked down on the host to read only, just as an extra security layer, I'm going to lock that down within the mappings as well. So we'll save that. Now, we need to let Bind itself know about this because we need to enable dynamic updates now. So first things first, I'm going to back up my config file. It's very easy to make typing errors, for example, and then things break. So this is going to be a bit easier to roll things back if something goes wrong. So once I've done that, I'll edit the config file. Now, I need to include that file we've created. So the idea is you just have the one file and you just keep adding multiple keys to it. And it'll just get included in this file when it's read. The good thing about this is if you need to do any like tech support, for example, you can just provide this file. Yes, they know where the actual keys are stored, but they don't know the contents of that file. So it makes more sense to include a separate file than include the actual, or rather than actually have the keys explicitly declared in the config file itself. So the next thing we're going to do is to enable dynamic updates. And it's, like I say, fairly straightforward. We're going to use the more modern update policy method. And then we're going to grant anybody who's got this DHCP.key key the ability to change A records and DHCID records for essentially any host in this .homelab.lan domain or zone. So this applies more for DHCP servers. Reason being is that once on, you would only just need to change A records, for example. I mean, this is only IPv4, incidentally. It doesn't cover IPv6. You'd have to add an additional record for that. But there was a change made to DHCP servers where they actually keep track of changes to prevent other clients being able to overwrite an existing record, essentially. So we've now got DHCID records being added by the DHCP server. Now, I also want to be able to do the equivalent for reverse lookups as well. So it's basically the same, except we're talking about pointer records. So this is the reverse lookup zone. So now we've done that, we've included our key, we've added the policies, so we'll save that file. Now there's a big change for the container. So first thing to do is to bring it down. And then once that's stopped, we'll start it back up again. So I didn't specifically mention the container to start because there's no need, all the rest are running. It's going to check through and it's just going to find out what's not running and then it'll try to start that one. Just double check that the container is up and running. So it's been up for quite a while. If there'd been a problem, you would have seen this restarting. It just wouldn't have stayed up for long at all. So that's good to see. Next thing we're going to do is to actually just double check the DNS itself, that the normal DNS is working. So I'm going to get it to resolve a fully qualified domain name. So that's tested the forward lookup zone. And then we'll do the same for the reverse lookup zone. Yep, so that's resolved that to pvedemo2.homelab.lan. So we know that DNS is still working in its normal state, but is dynamic updates now working? Now, before you rush off and start configuring your DHCP server, for instance, it makes a lot of sense to actually test that dynamic updates works in the first place. Otherwise, if the DHCP server can't update the DNS server, you're then going to have to find out, is the fault on the DNS server or is it on the DHCP server? So by doing this, we rule out the DNS server as being the problem. So I'm just going to switch to an account that's got sudo rights because I need to install some additional software. So I'll do sudo apt update first to update the package information. And then what we're going to do is to install DNS utils. That includes the NSUPDATE command that we're going to be using. We're then going to switch back to our Docker user here. And what I'm going to do is I'm going to create a text file because this is going to make it a bit easier to chain the commands together. You can call the actual file what you like. I'm just calling it nsupdate.txt. And then this is what I'm going to copy and paste in here. So the first thing we want to do is to connect to our DNS server. We're then going to delete any existing record for ddnstest.homelab.lan, for instance. And then we're going to actually add in an A record for that. So there's its FQDN, there's its IP address, it's an A record, and we've got a TTL of 600 seconds. We'll then get it to show what it's going to actually do on the screen before it then sends that information over to the actual DNS server. So we'll save that. And then we're actually going to run NSUPDATE. So we'll point it to our key file. Now the one thing to bear in mind is we can't, as far as I'm aware, get this to reference a specific key in the file. So later down the line, I'm going to have this key file containing multiple keys. So this is a one-off. After this, I would have to start creating separate files if I wanted to do that, each with their own individual key. But ultimately, I still just want the Bind9 container itself to be referencing that single file. So it's just something to bear in mind anyway. But in any case, I've got a -v option here to tell it to use TCP. That's just recommended for stability reasons. By default, it uses UDP. If there's too much information going along, it can cause issues. So yeah, using TCP probably makes more sense. It's a lot more stable. And then we're going to point it to our text file with a list of commands to actually run. So we're going to hit that, and then off it goes. Now, the key thing is it's come back and said status of no error. So as far as I can tell, that should have worked. But I'm actually going to use the dig command just to double check that that actually exists. So dig -t A record, and then there's the FQDN for it. So again, it's come back with no error because it hasn't had a problem communicating with it. But the key part is this answer section response. And it's come back and said that yes, there is a record. It's an A record, TTL of 600, and there's the IP address. So that aligns. So from what I can see, the NSUPDATE process is actually working. So we should be able to hand this over to a DHCP server, for instance, give it the key, and then it should be able to then start updating A records. Just so that you know, if we have a look at that actual file, the zone file, I don't see any reference in here to that new entry. The reason being is it doesn't necessarily go straight to the file. If we actually have a look in the folder here, you can see there's a journal file. So what it's doing is it's creating journal files as it goes. Eventually, it'll write the changes to the actual zone file itself. Because at the moment, everything just really runs in memory for Bind. But eventually it gets around to actually updating the actual journal file. So it's just something to bear in mind. If you don't see a record in the actual original zone file, it's probably getting queued up in this journal file ready to be sent over. But ultimately it does actually work, and that's the key thing. So what I'm going to do is I'm just going to remove that. So I'm just going to take out that add command and just tell it just go and delete that record. We don't need it anymore. So I'm then going to run my NSUPDATE command again. As far as the update section goes, it's saying it's gone, no errors reported, but all the same, I'll just double check. Yeah, now the status is NX domain. That actual record doesn't exist. It just doesn't know about it. So that's good to know. So what I'm going to do is I'm just going to delete my text file. I don't need it anymore. Now, going forward is where I've got my original dilemma. I really want to have static files separate to dynamic files. I don't want Bind really being able to make changes to static entries, but yeah, that's proven a lot more complicated and just not really practical to do. So it's something to bear in mind, which means that going forward, what you've got to do is maintain the zone file yourself if you want to add records yourself. And there's different ways you can do it. So for example, what you can do is run this command, docker exec bind9 rndc freeze. That basically freezes the database to prevent dynamic updates. Once you've done that, you could manually edit the actual zone file, increment the serial number, add or remove your own records, and then once you've done that, you can reinstate dynamic updates by running this command, docker exec bind9 rndc thaw. Now that's what I was probably talking about in a previous video using that method. Since then, I've been learning more about NSUPDATE, which makes a lot more sense. For one thing, it doesn't actually freeze the database, so it's a lot more practical, I'd say, probably a better way of doing that, but it's entirely up to you how you do that. But at least now we do know that you can actually make changes to DNS through dynamic updates. Now, my big concern with this is that existing records can be changed through dynamic DNS. By that, I'm referring to computers that have got a static IP address. So they've got what should really be a permanent record within the zone file, but it is possible to actually change that through dynamic DNS. So as an example, I'm going to resolve the FQDN for this computer, test2.homelab.lan. So that's an entry within the zone file. What I'm going to do is just show that we can actually change that. So I'm going to run nano to create our text file. And then what I'm going to do is, same as we did before, delete the existing record and add a new record. So this time it's going to have a new IP address. So we'll save that. Then we'll run NSUPDATE to apply those changes. And now, if I resolve that, you can see straight away it's coming back with a new IP address. That's a big problem, basically. So what I'm going to do is I'm just going to revert this back before I forget. So this is 102.101. again, we'll run the change for that. And then just double check that it is resolving to the correct IP address. Yeah, that's fine. Now, it is possible to actually prevent dynamic DNS from updating certain records, and basically that's what we're going to have to do. First things first though, I need to back up the configuration file, just in case we make a mistake. Then I'm going to edit the configuration file, which is name.conf.local. Now, what I'm going to do in this example is I'm going to add in a new command to the update policy. So I'm just going to tab that out just so that it's visible. And I'm going to create a new entry to actually deny an update for pvedemo1.homelab.lan. Now you'd have to do the same for your reverse lookup zone as well as your forward lookup zone. The key thing is the ordering here. This is kind of similar to a firewall in that it processes through the list and it stops at the first match. So we've got to put the deny policy at the top in front of this one, because otherwise if it hits the grant one first, it'll just allow the change to go through. So that deny has to be in front of this grant option here. And it's just basically anything. We're just going to deny any record that's got this name from being changed. So we'll save the change. Now what I'm just going to do in this particular case, I'm just going to restart the actual container as an example. So now what I'm going to do is just double check that this is up and running. So yeah, there's no errors being made there. I'm going to remove the existing text file for NSUPDATE. Just to make my life a bit easier, I am going to edit or create a new text file with a series of commands. And the idea is I'm going to get it to try to delete the A record, then get it to create a new record. So this is pvedemo1, so it's the server that the update policy should block us from being able to change. So then what I'll do was to actually run NSUPDATE. And what we should find is it should actually refuse this change. There you go. Updates refused. So it is actually possible to do this. It's just going to be a bit, I would say, fiddly. Reason being is, unless all of your servers have got something in common when it comes to the naming convention, you're going to have a deny statement for every single record that you want to be static and unchanged in this list. For me, that's not too difficult. I don't have that many computers anyway that have got a static IP address. But in the grand scheme of things, my plan is to actually get Ansible to build this entire file from scratch. It's going to build the actual zone files from scratch. The idea being is that I can actually create the entire bind container from scratch, and it'll start off with a fresh actual zone file that will get updated over time. But it'll also be able to actually build the config file as well based on those static entries that I've told it about. So that'll save me quite a lot of time and effort, I must admit, doing it that way. But you can always maintain this manually. It's entirely up to you. But the key thing is we've actually stopped that specific record, at least, from being changed. So that's okay when it comes to the dynamic updates. The one dilemma is that the actual user account in the container has got write access to the actual zone file. Now, if the service gets compromised, it can completely wipe out that zone file and start from scratch. In which case, the best thing you can do really is just keep the actual container and the software on it up to date. Make sure it's regularly getting patched to minimize the risk of somebody being able to connect into the DNS server and run some certain command or something that somehow forces it to give it privileged access to make changes and all this sort of stuff, and then it can start rewriting your zone file, get access to the container or whatever it is. That's something we can't control through this process. All we can do is stop the dynamic updates themselves changing records you don't want changed. But like I say, it's the best option I could find without getting into really complicated stuff, which involves using Ansible to go around and constantly check, is this entry in the record? Is this entry in the record? Oh, that shouldn't be there, I'll delete that. Oh, that entry's missing, I'll add it back in. Oh, that entry's changed, I better change it. It gets extremely complicated if you go down that line. And there doesn't seem to be a way that I know of to do this mechanism I was looking for, to have one file for static entries and one file for dynamic entries. It just doesn't seem to have been thought about, which is, it's a bit of a shame, but this seems to be the best compromise that I could find. Anyway, as far as I'm concerned, this all now works, and it would be something we could potentially put into production. Where you go from here really depends. Every DHCP server is different, so I can't really show you how to cover every single type of DHCP server. I did put a video out on how to actually configure Bind and Kia, for example, as a process of setting up dynamic DNS for that. So if you want, you can go and check out that video, because it's basically the same for setting up Kia on a container or on a standalone server. But as far as this video goes, that's pretty much it, except there is some additional tidy up work to do, shall we say. Now, it's entirely up to you, but I'd like to tidy things up for this actual container, because the way it's set up, it's running on version 0.3. I'd rather it be running on the latest version, in which case what we're going to do is to actually create another version of the image. So I'm going to swap over to my folder where the Docker file is, and then I'm going to actually get it to create a new image, but this is going to be tagged as the latest image. So again, my computers are all locked down. They don't have direct access to DNS servers on the internet, in which case I'm telling Docker build to only use an internal DNS server, whatever this actual host knows about. I can have problems with caching, so we're disabling that. And then I'm just telling what the name of it is, and in this case the version is the latest, and I'm going to be working in the present working directory. So I'll hit return. Then I'm just going to wait a while for this new image to be built. So now that the latest image has been built, what I need to do is to actually get the container to use that instead. So just switch back to the home folder, and what I'm going to do is to edit the Docker Compose file here. We'll then go looking for a Bind9 container. So what I'm going to do is I'm just going to take that line out. I'm going to uncomment that line, save the changes, and then we're back to using the latest version of the image. And then what we'll do is, because it's technically a different image, I'm going to stop the container or bring it down entirely, and then we'll start it back up again. It should be fine, but I'm going to double check all the same just to make sure that it's stable. Yeah, that's staying up. So again, it should work, but there's no harm in testing just to make sure that forward lookups work. Also check the reverse lookups as well. And as an extra measure, I'll just double check that internet resolution is working as well. Yep, that all seems fine. So what we've done in this video really is just to set up what would be dynamic DNS or dynamic updates for DHCP, for example. I mean, typically you would have different keys for different purposes. So for instance, I'll probably have one key for servers that need access to ACME so that they can work with DNS challenges. Probably have another key for, say, admin users so that they can do NS updates. another key for Ansible as well, so that it can do its own work, making changes to DNS. And once those keys are created, it'll all go into that same file. It'll really just be a case of updating the policy to decide what records can be changed by those different keys, and then effectively restarting the container for that to come into effect. Running services like Bind9 containers does present extra challenges, in this case file permissions. But containers need much less compute power and resources, which for me saves on capital and running costs. And now that I have a Bind container that supports dynamic updates, it can be used to support services like dynamic DNS and ACME DNS challenges. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.